Hi there, welcome to this tutorial on updating and contributing a Guix package. What we'll be doing today is updating an existing package that's already in the Guix archive, and then sending the updated package's details as a patch to the Guix maintainers. If all goes well, the Guix maintainers will review the patch and incorporate it into the Guix archive so that all users can use the updated package we've sent. This video is part of a series of blog posts and videos on Guix packaging. The main scenarios are set out here, and the ones we're focusing on today is modifying an existing package. Sometimes modifying a package means changing how it's building, but in this case we're going to be updating it. In this situation, there's already a package definition within Guix, and the upstream developers of the software have released a new version. Our goal is to update the package definition to reflect that new version. Sometimes when we modify a package, we're customizing it to our environment. The logical outcome is to run our own channel to use that customized version. In this case, it's a straightforward update, so we'll contribute our change to the main Guix package archive. This will mean all users will be able to benefit from the new version. For our example today, we're going to use Bugmatic, which is a backup front end, updating it from 1.8.13 to 1.8.14. This learning path should give a visual idea of what's needed to create an updated package. This first column are the user commands to create shell environments and build packages. The second column shows the various elements of a package definition. If we understand these, we can create and alter packages. Here on the third column are some of the tools and capabilities we'll be using to build the packages that are in Guix source code. When we're familiar with these capabilities, we can review packages and we can also create modified packages. Today we're focusing on modifying a package. In this case, we're updating the source. We won't cover all of the elements of the learning path in this video. That would make it a very long video. If you'd like to review one of the steps, see my site for blog posts and other videos. Ideally, this video would be how to create a modified package in 3 easy steps. And that's how easy it is to build a package normally. Unfortunately, it's not going to be as easy as that to deal with a modified package. Package updating and contribution is quite complex, so it's actually going to take us 23 steps to do it properly. Part of this is the manner of providing a contribution using email patches, and that may be unfamiliar to you if you're more used to Git pull requests. But actually most of the complexity is just inherent in making sure that a contribution is secure, correct, and works well when hundreds of people may use it. My goal is to make each of the steps clear and as easy to do as possible. The first step is some prerequisites that will make it easier to create and send our contribution. The first one is the source code to Guix itself. The Guix manual has a good section on how to build from source called Building from Git, so I'm not going to cover that here. The second one is the ability to send a patch using git send email. See the FutureR site for a post about how to do this. The third tool we'll be using is called StackGit. StackGit lets us treat Git commits like a patch. I like to use it because it shows each commit as a patch. This is the same view a Guix maintainer will have when they receive our patch. As the name implies, patches are visualized in a stack, and individual patches can be moved around in the stack very easily. Underneath the hood, it's actually doing this as individual Git commits, so you can fall back to Git if there's a problem. To install this in Guix, the package is StackGit at 2.4.0. This is a new rewrite of the tool in Rust. We'll also be using a tool called BTS to interact with Guix issues database. These are just the tools I'm using, and I think they do a good job, but there's lots of other options. For example, there's an Emacs mode for Guix, and there's a Guix tool called Mumi that deals with patches. See the Guix manual for more details. Step 2 is to check if the package is already being updated. We don't want to work on updating Borgmatic if someone is already doing it. Updates to packages can take a while to show up when you do a Guix pull. So it may be that a developer has already updated the package, but it hasn't made its way into the archive yet. If that's the case, we can test and review the patch to help the process. One place to check is the Guix Git repository. Search the log to see if there's an update to the package. Also check the issue tracker to see if there's a bug. It's worth knowing that Guix uses GNU's general bug tracker. This is a bug tracker for multiple GNU projects. The actual database and interfaces it uses is a bug tracker called Debbugs. As you can tell from the name, this bug tracker was originally developed for Debian. Debbugs was created back in the day when email was the main way of interfacing with it. So the interface is a bit old-fashioned, but it has some powerful capabilities. Guix has created a more modern interface called Guix Issues. This is the easiest way to interact with the bug database. So check Guix Issues to see if an update is already underway. Here I'm checking the Git log to see if there's an update to Borgmatic. And here I'm checking in the issues database, initially in Debbugs, and then in the issue site. As we can see, the Guix Issues database is much easier to deal with. From what we can see, there's no update to Borgmatic being worked on, so we'll update the package ourselves. Altering a package that's in Guix can vary in complexity. So in step 3, we check how difficult the update will be. One source of complexity is the upstream source changing. In particular, the inputs that it needs to build may alter. A good example of this is the Rust ecosystem, where the dependencies tend to move forward quickly. Sometimes the upstream source may change some other aspect of how it builds. For example, changing the build system. Python is an example of this, where there have been a number of methods to update packages. A quick way to check is to use a transformation. See my FutureR site for posts on how to do these. The second source of complexity is when a change impacts many other packages in the archive. This is where other packages need the package we're altering. Use Guix Graph to see the graph of packages in the archive. It can visually show packages that use the one we're trying to update. If a package is used by other packages, then we need to test all of them to make sure there's no unexpected issues. This is how we run the Guix Graph command. First we clone the Guix archive, then we use Guix Graph. Finally we can view the graph using xdot. Let's see that in the terminal. First we change to our Guix source directory and change onto the master branch. Here are all the branches that I have. As we can see, I'm on the master branch. Next I create a shell environment with the development inputs for Guix and add GraphViz as an additional package. We want to use the Guix archives package tree, so that's why we're using the git copy of Guix. To run commands with the git copy of Guix, we use the pre-inst env script and then the Guix command to run. Here we're running Guix Graph. The type of graph that we want is the reverse bag. This shows packages that directly and indirectly use Borgmatic. To view the resulting file, we use xdot. This shows that Borgmatic is on its own. No other package is using it. The result is that Borgmatic isn't used by any other packages, so updating it shouldn't be difficult. To start working on our package update, the next step is to create a Git worktree. If you haven't used these before, the advantage is that it allows me to work on multiple packages at a time. To use a worktree, we first switch to the master branch and update it. We check that the updates we've received have all been correctly signed off using the Guix Git authenticate command. We do this using our current standard Guix rather than using the one in the Git archive. Then we create a worktree for Borgmatic. All my worktrees are in the same area. You can see that I have a workspace directory and then Guix packages and worktrees is underneath this. And notice that when I create the new worktree called Borgmatic-1.8.14, I've also created a branch where the changes are being tracked, creatively called Borgmatic-1.8.14. In this case, it's a tracking branch against the master branch. Let's see those steps in the terminal now. Here I am on the master branch in my main Guix checkout. I update the branch to a specific commit. Then I check that the commits have been signed off by the Guix maintainers. Everything is correct. With that all done, I'm ready to create the worktree. The package update that I'm going to create will happen in this worktree. Step 5 is to initialize StackGit on the worktree. As I said, this is an optional step as you can just use plain Git. There are also other tools like Patman that help to manage a series. I like StackGit because it makes Git commits feel like patches, and patches is how Guix development is done. All patches are in a stack, and a patch can easily be moved up or down in the stack. I find this a really easy mental model for dealing with package contributions. The first thing to do is some basic configuration of Git in the worktree. Then to initialize StackGit in the worktree, we use stg init. All the commands are stg and then something. StackGit also has some commands for creating branches. In this case, we'll describe the branch and then list the branch. Let me show you that in the terminal now. First, we configure Git with some basic information about ourselves. Git needs this for email later. Next, we initialize StackGit on this branch. We give the branch a description, which I really like when I have a lot of branches. Underneath is just a normal Git branch and worktree with some additional StackGit metadata. Step 6 is to build the Guix source that's in the worktree. We're building the current master branch. To do that, we change the worktree and start a Guix development environment using Guix shell. As we did before, we provide the -- development Guix switch so that the shell environment has all the necessary inputs to build the Guix source code. I also provide a manifest, which has some tools in it that I use. To build the source code, the commands are first bootstrap, then configure, and then finally build it with make. We'll run this in the terminal now to see all of this in action. Here's the manifest with some additional tools in it. Now I start the build environment using Guix shell. Then I bootstrap the build using the bootstrap script. Then I run configure. Finally, I build the Guix source using make, and here I tell it to run multiple parallel builds. We'll leave that to do its thing for a bit, as building the source can take a while. And we're back at the end of the build with Guix compiled in this worktree. To package, we'll need multiple environments. This can be done with multiple terminals, or I use tmux and create one split for each environment I need. We'll create a build environment using Guix shell, and that will be used to build our package. A different Guix shell environment is used for testing the package. Then a dev split to run an editor in. This is a standard environment not using Guix shell. And finally, a hash split to use Guix hash in. Again, this is a standard shell environment, not in Guix shell. The build environment is in a container and nested with the development inputs for Guix, so that I'm guaranteed it is fully separated. It has access to var log Guix, so the build logs are sent there, and I can view those later. The test environment is basically the same, but has NSS certs so that the Guix lint command works. Finally, our dev and hash splits are just normal environments. Let's see those created in a terminal using tmux. I have 4 separate tmux splits. In the first one, I create the build environment using Guix shell. The main thing to notice is that I'm using Guix shell's container option for complete separation of these environments. In the second split, I create the test environment, again using a container. The third split is used for editing the package definition. And the last split is used for calculating the hash of the source, which is the next step. We're in step 8, which is to check that the source of the package hasn't been tampered with. Each package definition within Guix records a hash for the source files. When it downloads the source to build the package, it checks that the hash is correct. For our new version, we need to check the hash of the source files and add this to the package definition. In the case of Borgmatic, the Guix package gets the source from PyPy. What's nice about this is that we can check what the developer thought the hash was themselves when they published it. So then we're able to check that the source that we're getting is what the developer thought they were publishing. Having a recorded hash means that each time the Guix package is built, it will check that the source hasn't been tampered with by checking that it's receiving the hash it's expecting. Here are the commands we'll run in the terminal. Let's head there to see them in action. Here I am in the hash split. I use wget to download the source for the new version of Borgmatic. PyPy has SHA-256 hashes of their archives, so I run Guix hash on the source. I can check the contents of PyPy's archive matches what the developer thinks it should be. Yes, that matches, so the archive hasn't been tampered with. This time, I run Guix hash using the defaults, as this is the format Guix uses. When we update the package to the new version, we'll also update the hash to this. Then Guix will check this hash every time it builds the package. For our next step, we're going to update the package definition. First, we can find the file that we need to change by using the Guix edit command. Then we edit the package definition in the worktree. The two things we need to change are the version and the hash that we checked in the previous step. Let's do it in the terminal. Alright, here I am in the editor split, updating the package's definition. First I change the version to 1.8.14. And then I alter the hash using the one we got when we checked the source earlier. It's in the bottom split. All done. Having modified the package definition, we now need to build and test it. So step 10 is building the modified package. There are two things to check. The first is that the source location is correct and that the hash we've added matches the source download. The second part is to check that the package builds. It's worth going through the build log to make sure that there aren't any surprises hidden away. Here's how we tell Guix build to download and check the source. Notice the ---- source switch. And then we tell it to build the package. Notice the ---- no substitute switch. This tells Guix build to build the package and any inputs it doesn't have, rather than downloading them from the substitute server. Finally, we can retrieve the location of the build log like this. Let's run these commands in the terminal now. Here I am in the build environment. I tell Guix build to download the source, and we can see that it's successfully getting it. Next, I tell Guix build to build the package. As this is a development build, I use the no graph switch, as this speeds up the build by avoiding the grafting stage. Finally, I check the logs to make sure there are no hidden build or test failures. Step 11 is to install and test the package. As we know, building a package doesn't mean that it's working. It's perfectly possible to have a working build and a broken program. At the very least, it's necessary to install and test run the application. In the test environment, install the package like this. Then run it and try it out. As Borgmatic is a backup program, I would probably do a quick test backup. If a change is complicated and you want to test it further, don't forget that you can install a custom package into your general profile and use it there. Let's do those steps in the terminal now. In the test environment, I use the pre-inst env script to install the version of Borgmatic that I just built. Then I load the profile and check that Borgmatic runs. For a proper test, I would use the application to make sure it actually functions. Step 12 is to check build determinism. This tests whether, given the same inputs, the source and package definition, we get the same output package when we build it repeatedly. This is one of the security guarantees that Guix provides, as users can check that a package is building deterministically using the Guix challenge command. First, we want to check that the source we're using is always the same. We use the check flag so that Guix downloads another copy of the source and checks that it has the same hash as the one we downloaded earlier when we built the package. And we also want to check that the binary package build is deterministic. Again, we use the check flag so that Guix builds the package twice and checks the hash is the same each time. See the manual for more information on build determinism. Let's switch over to the terminal now to run those commands. Here I'm building the source with the check switch. Guix confirms that the two source downloads are the same. Now I build the package using the check switch. And again, Guix confirms that the two copies it has match. At this point, we've updated the package, tested that our updated version runs, and that it builds deterministically. We could use the package ourselves locally, or we could put it into our own channel. But we want all Guix users to benefit from the updated package, so we're going to create a patch and send it to the Guix project. In this step, we'll create a patch using StackGit. StackGit creates a new patch using the stgnew command. Each patch is one Git commit under the hood. We then need to create a commit message. Guix has a set format for this. See the Guix manual for details. We can update the patch with changes from our working tree using the stg refresh command. The stg series command is used to show a stack of patches. As we'll see, there's a patch I've already created, so there will be a stack of 2 patches. Finally, the stg show command will print out the current patch with the commit message. Let's pop into the terminal to see this in action. First, I create a new patch using stg new. This opens up an editor where I can add the commit message. I use stg refresh to add changes in the working tree to the patch. stg series shows there are 2 patches in the stack. To show each patch with stg show, either use its name or its number in the stack. Since we'll be sending the patch to the Guix project, the next few steps are to make sure our patch meets the project's quality standards. Step 14 is to check whether dependent packages need to be rebuilt. If there are dependent packages, then we must rebuild them and test them. Also, changes that cause rebuilds to a lot of packages may need to go to a particular test branch in Guix. We tested this earlier with Guix Graph. This time we'll use Guix Refresh. Let's see what this looks like in practice. First we check whether Python apres has any dependents. I sped this up as it takes a while to check the package graph. Just the one package uses it, Borgmatic. Then we check whether Borgmatic has any dependents. It doesn't, as we already know. So we don't have to build or test any other packages. For the patch to be accepted by the Guix project, it has to be correctly formatted and linted. To get the best code formatting, I use Emacs, as this is the style that most committers expect. I don't normally use Emacs, but I know enough to indent my code and exit quickly. There's also Guix style. You have to be a bit careful with this because older parts of the code base don't conform. I personally don't like reformatting an entire package if I'm just changing a few lines. The problem is the committer will receive a patch that shows changes to the whole package and won't know that only 2 lines have changed. A big change is less likely to be reviewed and committed than a small change. And generally, making something easy for a committer to review is the best policy. That's why I limit my reformatting with Guix style. Finally, Guix lint will check whether the package meets some of the project's quality standards, for example, formatting in package descriptions. It will also check for CVEs. Overall, running these commands will prevent a patch contribution failing review for lots of silly reasons. Let's run those commands in the terminal. First, I run Emacs on the backup.scm file, which has the package definition in it. Then I use the indent region command to format the package definition. Next, I run the styler. Using the dry run flag means that it tells me if it would make changes. There are no changes to make. Finally, I run the linter on both packages that I modified. It checks the quality of the package definition and makes sure there aren't any known security issues. For Python apres, ideally what I would do is update the package to a later version, as the linter warns me. Step 16 is to check that the contribution is in line with the project's guidelines. The Guix manual has a specific page on what's expected. Taking from that page, this is a checklist I've created for myself. The first item is that every patch that's sent should contain one discrete change only. Practically, this means that each patch updates one package only. Item 2. Make sure when creating a new package that libraries are packaged separately. Guix doesn't accept packages with vendored libraries. 3. Verify the source and ensure the package hash is correct. We discussed this in step 8 earlier. 4. The package builds correctly. We checked this in step 10 and 12. Bullet 5. The package works. We checked this in step 11. 6. The package builds on alternative architectures. Guix CI system will do this for us after we submit the patch, so there's no need to do this yourself. Item 7. The patch commit message meets the project standards. The project follows a version of the GNU changelog format. The easiest method is to look at previous commit messages. 8. The package only references other packages it needs. This is a way of making sure that the package tree is as small as possible. We did this in step 14. 9. The package is styled correctly. Checked in step 15. 10. Package synopsis and description are adequate. Be aware that some maintainers are focused on how factual the text is to try and keep it focused. Using the text from the project itself is often useful. Guixlint will pick up some of the technical issues such as the correct spacing at the start of sentence. Again, we checked this in step 15. 11. Package passes Guixlint. We checked this as part of step 15. 12. The patch should go to a topic branch of a team if possible. Examples of these are the Python team. 13. Packages that don't go to a specific branch should go to master. If it will cause a lot of rebuilds, then a topic-specific branch will be needed. For early contributors, I would avoid this if possible. Start with small changes to build up confidence and knowledge. Commonly, reviewing the checklist leads to some changes to our patch, and maybe some further rebuilds and tests. So step 17 is to now update our patch to the final version that we're going to send. I use these StackGit commands to do this. STG status shows me if there are some changes in the working copy. STG diff does a diff against the working copy. It's a light wrapper around git diff. If there are updates to be incorporated into the patch, then STG status does this. As there weren't any changes, we'll move on to step 18. We have a final set of patches, so the next step is to export them as emails, which is step 18. I'm using StackGit's email format command, which is a thin wrapper around git format patch. Doing this is going to necessitate a slightly different set of packages, so I've created an email environment. This has git send email in it and Debian dev scripts BTS. To avoid having to type GPG passwords in all the time, I use keychain. That's just something in my environment. The STG email format command creates the patch emails as files, and here I'm telling it to put them into the directory called stg-out. I want each email to be numbered so someone reading them knows they're a series. The base equals auto switch means that it will use a base commit automatically in the patch series. This makes it easier for a committer to apply the patch. I want the threading in the emails to be shallow. This means that there will be a cover letter email, and then all the other emails will be replies to the cover letter. I want a cover letter so I can add some notes, and the all switch means StackGit should export all the patches in the patch stack. Let's see what this looks like in the terminal. Here's the series of 2 patches. I use stgdiff to check the details. And now I'll show you both patches that I'm going to export. Next, I create an email environment using Guix shell. Now I'm ready to export the patches as email files. And then I edit the cover letter to provide information to the committer about the patch series. Before sending out the patches, it's best to check that they apply cleanly, which is the second part of step 18. It's worth doing this as it's the exact same steps that a Guix committer will try when they review the patches. If they don't apply cleanly, it's unlikely they'll be reviewed or pushed. Get the base commit from the cover letter. Create a new branch using the base commit. Then apply the patches using git am. There are switches that maximize the chance of a patch applying, but they shouldn't be necessary when doing this sort of test. Let me show you these in the terminal. Here's the cover letter with the base commit. I change into my main Guix repository and create a new branch using the base commit. Now I'm ready to use git am to apply the two patches I exported earlier. They apply cleanly. I use git log to see the commits. If there's an active committer for a package, a patch is more likely to be noticed and reviewed. Some areas have teams, one or more individuals who looks after the packages in a particular file. An example of this is the Python team. There's some magic in the Guix archive's Git settings, which will run a script when a patch is sent. This will automatically CC a team depending on the file that's changed. This won't add people to the CC when sending the cover letter. We have to do this manually. To find out who should be CC'd onto the cover letter email, use the getMaintainer command for each patch file. To generally understand if there's a suitable team, there are some other useful commands. Let's run these commands in the terminal. First, I change back into my working tree. Then, for each patch, I run getMaintainer, which is a function in the teams.scm file. Python apres is of interest to the Python team, so we can CC them onto the patches. As we can see, there are lots of other teams in Guix, and it's easy to join one if you'd like to contribute to an area. Alright, we're making progress. Just a few more steps to go. Now it's time to create a bug in Guix's bug tracker, which, as we noted earlier, is GNU's shared Debbugs. If we send a series of patches to Debbugs, then as these are separate emails, it thinks we're creating separate bugs, when what we want to do is to create a single bug with multiple patches attached to it. To make this happen, we send the cover letter to the Guix patches mailing list. Debbugs will automatically create a new bug when it sees the email. After the bug is created, we send the rest of the patch series to the new Debbugs bug number. This will attach the patches to the bug, and it will also reflect them to the Guix patches email list. So for step 20, we're going to create a new bug by sending our cover letter to the Guix patches mailing list and CCing the appropriate committers. To send the cover letter, we use git send email. We added most of the options we need when we used the stg email format command earlier, so this step is simple. If there are committers, we add them by using the CC switch. When you use the getMaintainer script, it shows the email addresses as a special type of x-debbugs header. But this won't work for the cover letter email because we're sending it directly to the Guix patch mailing list and not directly to Debbugs. So add the committers by using the plain CC switch. Shortly after this is sent, we'll receive a new bug number from Debbugs by email. Let's see those commands in the terminal. I use git send email to send the cover letter directly to the Guix patches mailing list. I use the annotate switch so I can do a final review of the email. This is the same command, but this time I've added the CCs that were identified earlier. Cover letter's been sent, and Debbugs replies with a new bug number. For step 21, we thread the patches that follow the cover letter and send them. The reason for threading them is so that anyone reading the series will see them clustered in their email reader. That makes it easy to see that they're related. The way we're going to do this is that all the patches will appear as replies to the cover letter that was sent earlier. To do this, we need the message ID from the header of the cover letter. We can get this either from the Guix Issues website or by using the BTS tool. Use BTS like this to retrieve the bug and read it in an email reader. Then search for the message ID header. Alternatively, go to the Guix Issues site and get it from there. Then re-export the patches as emails, this time using the reply to address and sending the email to the bug number. There's no cover letter. Instead, the in reply to switch references the message ID from the cover letter. This time, the emails are going directly to the bug number that we received from Debbugs. Debbugs will reflect them to the Guix patches mailing list. The Guix automation will automatically add the right CCs for files that are covered by a team. In this case, the Python Apres patch is in a file that the Python team looks after. However, if we want the rest of the patch series to also go to the Python team for review, then we have to add the headers. As we're emailing directly to Debbugs, we can use the x-debbugs-cc special header. This will mean that any subsequent emails to this bug number will also go to the same people on the CC. Finally, we send the patches using git send email directly to the Debbugs number. We can see these commands in the terminal. I retrieve the bug using the BTS tool. The nice part is that all interaction with the bug can be done offline. Then in Mutt, I search for the message ID. I can also get the message ID from the Guix Issues site, like this. Now I'm ready to re-export the patches, referencing the message ID. I add a special Debbugs header to add the right team onto the bug. Debbugs will then CC them onto any traffic for the bug. The last part is to send the patches. Having sent the patches, step 22 is to check that they pass the QA process. If the patches fail automated QA, it's unlikely that they'll be reviewed. Start by making sure that the patches have been attached to the bug number on Guix Issues site. Then check if the QA system has tried to build the patches. Patches can take a few days to be processed, depending on how many others there are in the queue. There's a badge at the bottom of the QA page for each specific issue. This shows its status. If it says unknown, then it hasn't started building it yet. To see where a patch is in the queue, check the QA patches page. Here's the bug in the issues site. Here I'm checking whether QA has started building it. And here I'm checking where it is in the queue. I would show you a screenshot of the patches building, but ironically, mine failed that part. If a patch has an issue or there's feedback from a reviewer, then make any changes that are needed and re-roll the series. Use STG email format like before. Use the re-roll count option, which will put a version into the subject. The re-roll count is the number of times the patch series has been sent. When we originally sent the patches, that counts as the first time, so any changes means that we're re-rolling for the second time. I also send a cover letter to explain what's changed. I create the patch emails using STG email format just like before. I use the re-roll count option with a count of 2, as this is the second send. When sending the patches this time, I send to the bug number. I already added committers using the Debbugs header, so the bug tracker will automatically send them the updated patches. Now, the only thing to do is to wait. As a volunteer project, there's only a few people who can review and commit patches. There's no doubt that waiting is hard, and unfortunately, some great patches don't get reviewed. Don't forget, you can use the patch yourself locally and share it with others by running your own channel. If no one looks at the patch for a few weeks, let's say 3 or more, try following up on IRC a few times. Let's assume that a committer reviews the patches and applies them. First, congratulations at getting your contribution into Guix. Since everything is done, we can do the last step and remove our local work tree and branches. Let's see this step in the terminal. Here, I change into my main Guix checkout. Then I remove the work tree for the Borgmatic update. Then I remove the Git branches. That's it. That's all the steps involved in modifying a package and contributing it to the Guix project. I know that took a while, so well done sticking with me. As we've seen, making sure that our modifications are at the right level of quality involve quite a few steps. But ultimately, that ensures that you as a user have a great experience using Guix. Hopefully, I've shown you that tools like Git worktrees, StackGit, and Guix's automated CI can help. Primarily, we have to have some patience, as it's a volunteer project, so patches may not be picked up immediately. That's everything for now on how to modify and contribute changes to Guix. If there's an aspect of this video that was a bit unclear, or you'd like more details on something, please leave a comment below. The next steps from here are making more complex contributions or running your own channel. There's further material on my Guix resource page. If you'd like to learn more about Guix, check out the main site and come along to the Guix social meetup. That's the end of this one. Thanks for watching.